Good evening.
Hello, good evening. Good evening, everyone. My name is Bernard, and this is Space Oddities, our weekly meeting to discuss astronomy and everything about space. We have with us a panel of professional astronomers and amateur astronomers, and we all like to have a good conversation, a good discussion about deep space and our solar system, space industry, space policies, anything related to space, you name it, we'll talk on this show. We have, how many panelists we have? 1, 2, 3, 4, 5. We have 8 panelists tonight with us. Sometimes we have more, sometimes we have less. I had COVID, unfortunately, a few last week, so I couldn't join. But thank you so much for being here with us tonight. Before I start, please do not forget to subscribe and to like the video. This will allow us to make more videos like this and to have much more fun with yourselves. So, hello everyone. Let's all start by saying hello everyone.
How are you?
Hello.
I'm good. I hope you're all doing well all over the world. And why don't we start with Roger, who is going to talk to us about what we can see in the night sky.
Okay, everyone. Okay, it'll be the usual format. So here we go. I shall start to share my screen. Right. Okay, so here we are for the week of the 18th to the 24th of July. And for that, we have we've gone now past the last of the supermoons of the 2022. And we're now into the waning gibbous and waning crescent with a third quarter this coming Wednesday. And while we're looking up at the daytime sky, here are some sunspots that I've taken during today. And still gathering pace with the solar maximum coming up in a few more years and showing some interesting groupings still coming around the limb. And here's a little animation coming up on the next slide of how things progress as the sun rotates in our viewpoint. Not every day, but most days. So it's showing a interesting group north and south of the solar equator. So hopefully we'll be getting some more good groupings on there.
Nice.
That's really nice, Roger. What's the time shot timeline on this? Is it a picture every day or every half day?
Yeah, most days between the 10th and the 18th.
So every day, one shot. Okay.
Yeah. So yeah, showing quite a reasonable bit of activity.
Yeah, absolutely.
Okay. Right. Okay. So apart from the initial release of the images from James Webb, it's now pointing its way over to the planet Jupiter. And in the mid-infrared camera and the low-infrared camera, you can even see the ring around Jupiter, which is quite interesting to see. And the great red spots looking rather glorious there in that image.
See, this is the problem of looking at stuff on a mobile. When I saw the image on the mobile, they said, oh, it includes the ring at Jupiter. I can't see a ring. I can't see a ring. It was only when I put it on a big monitor that I could actually see what they were talking about.
Well, one of the first images that they published in the news articles, they actually had overexposed it and the rings had disappeared. You couldn't see them.
Oh, well, that may be it then.
Yeah.
That was probably the one you saw.
Yeah.
Here's a couple of more images here.
Sorry,
which
Roger.
shows some more and a couple more of the satellites here. We've got Europa, which is blanked out, but it's also got Thebe and Metis, another couple of much smaller of the many moons that Jupiter has now. And yeah, it's very interesting.
That's Europa's shadow to the left.
Exactly.
Red spot.
Yeah.
Looks like a nice pancake on the right, though.
Yeah.
Yeah.
Got lots of sprinkles on there.
And this photograph was taken as part of a test to see whether Webb could actually track comparatively fast-moving objects like planets in the solar system. And I think it's proved that that it can magnificently.
Yes.
So that's great news. I can't wait till they look at the ice giants, for example. That should be spectacular.
One of the things I was reading was the images of Jupiter were happening while it was tracking an asteroid that was in the same field of view, and they doubled their estimate of the speed at which they could capture fast-moving objects to, I think, 67 microarc seconds per minute or something like that. It's an incredible achievement they can track asteroids moving in our solar system with the James Webb.
That's amazing. Daz?
Yeah, Derek in the chat, he's asking, what are the black spots? My answer is it's dust on the lens. But yeah, does anybody have any idea? I shouldn't think it'll be dead pixels, would it?
No, it might be just specks on the sensor on the camera chip, I would have thought.
Or it could just be electronic noise.
I was going to say, it looks
Maybe.
like noise to me.
More likely.
Yeah. Anyway.
It's a random enough distribution.
Yeah.
And of course, Europa has that big black spot in the middle because it's overexposed. It's overwhelmed the sensor. Too bright. The big black mass to the right of Europa, again, that's equipment problems, I should think, or characteristics.
Anyway, onwards and outwards. Right, the week ahead of the planets in the morning sky, we've still got 4 planets still visible, and as a matter of interest, on the 19th, which is tomorrow, we've got the moon just below Jupiter, and it's within 2 degrees. So that could make an interesting picture if you want to be up in the middle of the night to do that image.
What's that, 2:30? Is that in the morning?
Well, it's about 3 o'clock or so. There.
About 3 o'clock. That's 48, is it?
Yeah.
Right. Okay.
Roger, I'm afraid that's very inconvenient. Isn't there something you can do to make these?
I'm afraid not. Beyond my control, I'm afraid. As you can see, the also goes down below the moon, but that will happen when it's visible during the southern hemisphere, I'm guessing.
Isn't it when we manage to get 500 subscribers, we can do something about it?
Oh, maybe.
Something like that.
Yeah.
And if we have any viewers on our channel in the southern hemisphere, this is what you expect to see during your winter, with Orion rising up and the planets still higher in the altitude in the sky than what we are currently expressing. So lucky them to get better visibility of the giants. And that's all I have for this evening.
Well, thanks for that, Rog.
That's great.
Yeah.
Cool.
I'd just like to add to that we're also in officially now Perseid meteor season. It officially started yesterday on the 17th of July, and it will run till the 24th of August. But of course, the main peak will be about the 12th or 13th of August. That's for me. Of course, the meteors are the result of the passing of 109P Swift-Tuttle comet. So every year we come round and we pass through the tail and the debris, and we get these excellent shows. A lot of people like to watch this one because I think, as Andy pointed out, it's in the summer, so it's not so cold. So lots of people like to go out. At its peak, if you're in a very dark area and you can get away from light pollution, you can see between 60 and 80 meteors an hour. I was out last night trying. I think I may have caught one. I haven't gone through all the photos yet, but I did think I see Mary, who's not here tonight, and get well soon. She caught 2, I think. So it's good. So yeah, we're into the. Okay, if I can just share my screen, let me just show you where you can actually find them. All right.
And then Steve will want to say something.
Okay, then. Right. So, as well as, excuse me, as well as the Perseids, we have 4 other showers on the go at the moment. We have the southern aquarids, and two sort of types there, and you can see them very low on the horizon. So now these are called, where the spots are, these are called the radiant. Now this is the direction that the meteorites will actually be coming from. Now if you want to capture photographs of these, that is the one place you don't really want to be. If you're concentrating on that area there, even if you're just using your eyes or binoculars or anything like that, you will be seeing meteorites that are coming almost directly at you if they come from that point there. So you'll only get a brief flash or maybe just a small trail. What you need to do is you need to come off about 30, 45 degrees to the side of it, set up your camera, get the remote going, and just clip away 15, 20-second shots, and then hopefully you will catch some. They're pesky little things. They're very hard to see. And of course, usually we get clouds come in when it gets all exciting and it really kicks off. At the moment in the Northern Hemisphere, as I said, I went out last night. I didn't go out until about 20 past 12, but even then it was still light. We're not really getting astronomical darkness for any length of time. So you can still, with a camera, the camera is far more sensitive. It will pick up the stars, and you will be able to pick up, capture any meteorites. But as I said, we've got the aquarids down the bottom here. We've got the Capricornids, and we've got the June scutids. You can see where they are next to the constellations. You've got Aquila there, you've got Scutum there, and of course you've got Aquarius down here, and this is where most of them get their names. Now we're talking about the Perseids, and as I said, these will go on to the 24th of June, I think I said, was it? August, sorry, I'm on about June. And this is where you will find them. It's quite high in the sky. It's northeast, and as you can see, it's between Cassiopeia, Andromeda, and you can see just a thing. Can you see my cursor?
Mm.
Yeah,
Yes.
that's the Andromeda galaxy just there, and there's Perseus there. So again, if you want to take images, and remember, these meteors will appear anywhere. But what you do is, if you trace the way back, is they'll come round to here somewhere. But they can appear anywhere in the sky. They can even appear behind you. So you need to be sort of like in a prone position as much as possible, so you can see as much as the sky as possible. And if you've got two cameras, get them both working in different directions, and you stand more chance of catching them. Sorry?
So I was going to say, it's worth pointing out the peak night of the Perseid is over the 11th and 12th of August.
Yeah.
Or is it the 12th, 13th? Never remember.
12th or 13th of August.
Yeah,
that's the peak.
That's the peak
for us. Yeah.
When you might see 60 meteors an hour. I can't remember this year if the moon's going to interfere.
Yeah, that's the hitch. I think the peak corresponds pretty much with the full moon thereabouts.
Well, that's about right, isn't it? It's either moon or clouds.
Yeah.
Yeah. You wanted to say something, Steve? Was it?
Oh, sorry. That was it. Can you hear me?
Yeah.
Yes.
Yeah. No.
Yes,
No. Okay. No. I just thought you wanted
it was about the peak being full moon. We at Mac Astro, we organise a field trip to go out to dark skies to coincide with the Perseid peak. And we have seen about 50 meters an hour in the past over in dark skies, but it's going to be less this year.
Yeah, because I've just checked, and it is the 12th is the full moon.
Oh,
so that's deep joy. So again, we're going to have them, but like I said, you can catch them before, and you can catch them afterwards. So have a go, even if you just want to watch with the eye.
You can still see the very bright Perseids. You should still be able to see some if you're lucky, but obviously fainter ones you won't catch like you normally would.
Yeah,
I think Lou has been trying to put it.
Just a small point about photographing these. Absolutely correct that if you don't want star trails in your image, 15, 20-second shutter speed is about right. But you could leave if you have a camera that can just leave your aperture open for much longer periods, we'll see the stars in their natural dance across the sky, making trails. But you'll also see meteors flashing through that. So you'd have maybe a little bit better chance of catching meteors if you just leave the camera wide open for longer periods of time.
Cool.
Okay. That's great. Thank you. Well, good meteor hunting.
And I mean, depending on wherever everyone's listening to us here, but in Europe it's quite warm at the moment. So I would hope that, the weather would still be not as warm, but still warm enough and pleasant enough just to go out and look at the night sky. Cool. Thank you very much for that, Roger and Daz. And may I remind the people who are listening that if you do have any questions, please don't hesitate and put them in the comment section of the YouTube video, and we will read them and reply to them live on air. So now we're going to move to one of our favorite parts of the session, which is we're going to be looking at images that people have submitted to us. So we're going to move to Rachel. Rachel, what do you have for us tonight?
We have some. We had that many entries for this week's show. I've had to not use everyone, so I'm really sorry for those people. You'll have to wait for next time. But we've got a good mix this week, so let's have a look. Okay. So we're starting off with an image from the sun. We've got a rival for Mr. Kev. We've got someone else on the sun game.
No, surely not.
So this one's by Michael Murphy, image from Dublin, and obviously his techie details are on the screen. And I really like this one actually because it's rare you get one like this in black and white.
Hold on, Rachel. I can't see anything on the screen.
We've just got the poster.
Yeah.
You still not see it?
No, we're not seeing the slides.
That's strange. Let me share it again.
We could see the first slide, but not the next.
That's strange. Let's do it this way. I'll just share my screen, and then we will.
Oh,
there we go.
That is wonderful.
I'll
Well done, Michael.
I'll end the show and go back from the beginning. I don't know if it's going to show me in presenter mode. That's all.
Try again. So we see the first slide.
That's the first slide.
So here we go.
There we go.
That's it. Yeah, that's it. Yeah.
So yeah, so it's rare you get a sort of, well, I don't see them very often in black and white like this. So I thought it was really lovely. I don't know the techie words for it, but I just love the edge around the outside, which is really, really stunning. So thank you, Michael.
Can I ask? That's such a stunning picture, and I rarely see the picture of the sun with these lines interlacing the sun like that. That's phenomenal.
Well, you mean the long snaky lines?
Yeah. What are they?
Yeah, they're the filaments. They're like the prominences on the side, but I've actually seen on the face of the actual sun. And the white bits, I think they call them plages. Do they? Plages?
Yeah. Yes.
Yeah, which is French for beach. I don't think there's a beach there somewhere.
No.
You'd like to be on it if there was.
Yeah, so
we've got a beach that hot in Spain at the moment.
Yeah, it looks hot.
Yeah.
I think that's about what my AstroTurf feels like under my feet at the minute.
Yeah. Yeah.
And then we've got a lovely entry by Lee from Cornwall. So he's gone for NGC 7380, also known as the Wizard Nebula. And he sent this in this week. I know he's been trying really hard again. He's really patiently. I sort of get bored and move on, but Lee's always messaging me, showing me the latest update of what he does, and he's so persistent. And it obviously pays off for him. So
Wow,
lovely little wizard, Lee. I really don't understand people when they say they can't see the wizard. I think it's so obvious, but it's lots of people say they don't know where it is. But I think he looks cute. Then we've got one by Mario, who's sent in a Jupiter-Europa shadow transit. And he said that he tried imaging some planetary last year, and this is one of his best images that he's taken. And he also just wanted to say he really enjoys listening to us all each week. So thank you for that, Mario.
Oh, thank you.
hey, sweet.
I love having you here too.
Oh, that's a lovely shadow, isn't it?
Yeah,
that's beautiful.
I like that.
It's really nice.
The first time you ever see one of those through a telescope, it's mesmerizing. It's just absolutely unbelievable. You can just stand there for minutes and watch that shadow move.
Yeah, because I mean, using remote telescopes, because it rotates. Is it every 20? No, 9 hours or something
9
like
hours,
that?
yeah.
9 hours.
You can actually in the winter, and well, I did it on with remote telescopes. Actually, made a small video of the whole orbit of
Oh, right.
the whole from red spot from over there coming over there, and then it was just appearing around here again on the
Wow.
next trip, and it was it was a good night. That was good night. Enjoyed that.
There's a lot of detail there, right up towards the poles as well on that.
Yeah.
It's really good.
That's really nice.
It's remarkably flat, isn't it, in terms of resolution? It's a great image, Mario. Well done.
Well done. That's nice. Yeah.
Thanks for sending it in. Thanks to everybody for sending their images in. Love looking at them.
That's okay. We've got an entry of the Pelican Nebula, which I believe is in Cygnus off the top of my head. So this is around 3 hours integration time, taken in one session. And obviously it was just done this June recently. So Andy has sent me in this way. So I'll show you it as the rotation, but obviously with it being portrait, it has to be slightly smaller to fit on the screen. So I have rotated it as well.
Oh, wow.
Just so we can see it a little bit closer, because I think it's a shame to not. But again, yeah, I just like everything. I love the colours, the illumination.
That's amazing.
It's a James Webb image, isn't it? Glorious.
It's good as. Very
But
nice.
yeah, I like how Andy he really gets in on parts. Obviously, normally you used to see the Pelican as quite a a full piece, but I like how Andy actually does take really small parts of a nebula and focus in. And then to finish, I believe we've got an image by Ed Holt, which is, we've been having a debate if it's Clavius or Clavius, but it's Tycho to that crater in infrared. And I'll just leave the stuff there a second for you to have a quick look. And then here it is. So
it's clear and nice, isn't it?
Lovely.
yeah, you almost feel like you can see the texture. It's strange.
The shadows are amazing.
Yeah.
So,
One for Mary to draw, I think.
yeah, definitely. In fact,
that's very nice.
with Ed's permission, I might ask if I can use it and have a go over the summer holidays at that one. So, and that's where I've stopped it this week, because I could have gone on. We had so many more, but I thought I'll save some for next week. So
That's
yeah, thank you
brilliant.
everybody, and I'll put details in on how to send your things in again.
Well done. That was very good.
Yeah.
Well done, everyone. Thank you for that.
Everybody. Thanks for the images. We love them. We love them.
They're really stunning. Yeah, absolutely. Please do not hesitate to submit more pictures to us. Thank you so much again, Rachel, for doing that. And yeah, it's just great. Okay, let's move on. Why don't we go to Canada and see what's up with the Canadians? Kareem, how are you?
I'm good, just trying to get my computer to work again. I'm doing great. We have had some awesome outreach the last week or so. We have this thing here in North America called SHAD, and it's a STEAM camp for senior high school students. And our McGill campus here in Montreal has been doing it for several years now. Since 2018, it was the first time that McGill got a chance to run a SHAD campus. And so those first 2 years pre-COVID, we did observing on the field with them, and it was just a blast. And so the last couple of years with COVID, the whole camp and everything had kind of shut down, and some virtual activity was all they did. This year they were back in person. We got them back out on the field, and there were clouds. But we managed to get set up a bunch of telescopes, and they just loved talking to the RASC astronomers and getting a chance to see their astro images on their tablets and hear about their process and just see the instrumentation and be out on the field. And then just at the end of the night, as they were heading back to the bus, the ISS passed over. And so they got to see that ISS pass. And then as they drove in towards the downtown McGill campus, the moon rose, and it was just wonderful. It was a nice way to end the evening for them.
Fantastic.
Yeah, I mean, I love sharing that type of an environment. And I just actually 5 minutes ago got a message from RASC New Brunswick, and it looks like I'll be doing an outreach talk for them tonight. So, it's a fun one to do virtually as well. What I wanted to share tonight was something a little bit different. I know a lot of us love planets, and we love talking about different planets. And I know Roger just shared with us that beautiful the JWST images of Jupiter. And Jupiter has astounded us for a long time, not just for amateur astronomers to look at through their telescopes and see the stripes and see the great red spot, but when the Voyager probes first approached and sent us this beautiful video clip, you know, our imagination ran wild. We loved the idea of Jupiter, and I know a lot of us remember Carl Sagan with the Cosmos episode where he talked about the idea of life on Jupiter and what it might look like. But what my personal connection with Jupiter has been the last few years is knowing David Levy, one of the discoverers of Shoemaker-Levy 9. And we had him on Astro Radio and Reach Out and Touch Space just in this last year before we ended up closing down. And right now we are in the 28th anniversary of Shoemaker-Levy 9 impacts. And so I just wanted to take a few minutes to share with you a little bit about Shoemaker-Levy 9. And this is that first developed picture of all the images that they had taken showing that there was this really elongated mess of little dots that seemed to be on a comet-like trajectory. And when they worked out the trajectory, they realized that the comet had broken up a year before the discovery. And then they realized, lo and behold, that in less than a year, or just over a year, it would be impacting on Jupiter based on the current dynamics that they saw. Now, this was all in March 1993 that they discovered this. And David Levy tells the story, and I'll leave it to him or for people to look at some of his previous presentations to hear about that story. But what I wanted to discuss was the actual observations, because those happened 28 years ago. This past weekend started the very first observation from July 16, 1994. And we saw nighttime impacts glowing off the night side of Jupiter. We saw individual impacts that Hubble was able to focus in on. And when Hubble was able to focus in on it, it was actually able to follow it over years in time to see the evolution of these plumes as the cloud-like structure of Jupiter managed to wash them away. But that's not all, because when the Galileo probe went through the Jupiter system, it saw ripples in Jupiter's rings due to the passage of Shoemaker-Levy 9. And that part just astounds me, because not only did Galileo see the ripples, computer simulations of what we believe after Voyager, after Galileo, that those rings were composed of, showed that same type of behavior that we would expect to happen when these small objects, I mean, the actual comet that created Shoemaker-Levy 9 was less than 2 kilometers in size. And that broken apart could cause these ripples within the rings. Now, we got to see the infrared of Jupiter from James Webb. I want to remind people that we've been watching Jupiter in infrared with the facility on Mauna Kea for a long time now. And with that facility, we were able to image those impacts during that time in 1994. So tomorrow night, we have a global star party on Explore Scientific YouTube channel. It starts early at 3 p.m. Central Time, and David Levy will be on at 3 p.m. and again at 6 p.m. with poetry readings and talking a little bit about this anniversary. And here he is with his good friends who've unfortunately both now passed away. And they're friends of a lot of the people on this panel, including Mary is really, you know, she was torn up when Carolyn Shoemaker passed away. Gene Shoemaker's remains are actually on the moon. And what I love is that all the way up until Gene's health troubles, they were active in the amateur astronomy community. This is a picture of the three of them at Stellafane 2002. Now, this year, Stellafane is in 2 weeks in Springfield, Vermont, and I will actually be there. I'm looking forward to it. It's an amazing, just a group of people who are telescope enthusiasts. There's telescope making competitions and everything. So if you're a fan in the US and you haven't been to Stellafane, you definitely need to. And if you want to hear more from David Levy, join us tomorrow night on the Global Star Parties. That's it for me.
Thanks so much.
Thank you for that. That was great.
Really
Thank you.
Really interesting.
Yeah, when he was on the radio, he was a fantastic guy. Very, very entertaining, very informative. Very, very nice man. And as you said, he loves his poetry.
He loves his poetry, but also his humanistic stories. You know, he was talking about Halton C. Arp just the other day on email with a few of us about the fact, because when the Stefan's Quintet that's behind Lou right now, when that picture came out, people were talking about the fact that since there's 4 of those galaxies gravitationally intertwined, but the 5th one isn't, they didn't know that at the time. And Halton C. Arp was trying to figure out why the redshifts were so different and was proposing, out of the box theories and being ridiculed for it, when all he was trying to do was say, look, let's just not go with convention. Let's make sure that we're exploring all possibilities. And David talked about, having these discussions with Arp at Palomar. And just the human side of astronomy is just beautiful to hear from him.
Absolutely, absolutely. And of course, each one of those impacts on Jupiter, particularly the big ones, exploded with the force of thousands of Hiroshima-sized bombs. They were incredibly huge impacts, and those scars that they left, visible in even small telescopes for weeks after the event, it was an amazing time.
It was a time when every telescope and every spacecraft that could was observing Jupiter, because just as you drop a pebble into a lake and it splashes, we were interested in finding out what the deeper parts of Jupiter's atmosphere, what the composition was. And I think there were even some bets going on, as I remember, as to whether they would find water in the splash.
In the spectra,
in the spectrum. And I don't think they did, but that is probably because it didn't splash from deep enough in the
and when Galileo dropped its probe into the Jovian atmosphere, they were worried because they detected hardly any water, which they were really expecting. And then it turned out that they'd just been unlucky that the probe had actually dropped into a particularly dry area of the Jovian atmosphere. So if we repeated the experiment, you'd probably see a lot more water.
They did get plenty of ammonia, though.
They did. Well, that's to be expected.
No, I love talking to the students about the size of the impact craters versus the clouds that you normally see on Jupiter and versus the Great Red Spot, because the relative size of these things is just impossible for them to fathom, because they've always seen those models that just show Jupiter bigger, but they don't show the actual scale of sizes.
Absolutely.
I wonder how often such an event as that impact occurs, because it's just extraordinarily fortunate that we've been able to witness it.
So individual impacts, I mean, we see those often now on the moon and on Jupiter because there's so many telescopes trained at them. But something like this, where you actually divert the path of a comet, tear it apart, and then it collides, I don't know. It might be the first time since everything was in the creation stages of the solar system when there were these constant impacts. We don't know.
No, we don't know.
The other thing I didn't realise from Roger's presentation, I didn't realise that Jupiter's ring was quite so close into the planet. Actually, that was a revelation to me.
It seems to clearly be it's well within the Roche limit, so it seems to be a moon that was torn apart.
Did we manage to find or to at least to have a bit of idea as to the composition of the comet that struck Jupiter? Was it more icy? Was it more rocky? Or we just didn't really manage to get that, amongst all the measurements and all the observations we made?
I don't know. I haven't read.
I think if it's a comet, it's going to be largely ice, isn't it?
Well, you would expect.
We would expect. But then you would have expected to see some water in the spectra of the explosion in the plumes.
True. Yeah.
That's where I was getting at, is that we do you mentioned, Lou, that we couldn't find any water in those plumes, but I would presume that we would probably also find elements from that comet itself within the plume. Hence why potentially might be able to identify some of the aspects of that comet.
I think we should say we didn't find water to some limit of measurement. The frozen water or frozen CO2 in the comet may have been in such small quantities that, given the huge splash in the atmosphere, was just not a major constituent.
Yeah. As a reminder,
that's valid.
The size of the comet, you said, Karim, was like 2 kilometers in diameter, so it's just
and
so
broken
small.
up into 24 pieces.
Yeah. Yeah, the chunks are really too small to make a difference. Cool.
But that also tells you just how strong Jupiter's gravity is to take some object that's passing by and break it up into so many different components and alter its path so that it will now use Jupiter as its gravitational target.
But that's always been, as we understand it, that's been the history of the solar system, hasn't it? With Jupiter attracting these comets and asteroids towards itself, thus saving the inner planets from bombardments. Although I did read a bit of a paper recently that said that idea is now under question for a reason I can't remember. But anyway, that's the general idea, that Jupiter protects Venus, the Earth, and Mercury from huge bombardments by acting as a sort of a cosmic vacuum cleaner.
Which makes it incredibly fortunate that it's further out than our inner solar system.
Isn't it? Yeah. Yeah. Well, we might not be here otherwise. I mean, you never know,
Cool. Well, thank you so much for that, Karim. That was super interesting. And yeah, it's a great way to remember that event. Very good. Well, very good. Andy, since you were talking, why don't we go to you? What do you have for us this week?
Well, I'm just busting to tell everybody out there about a new discovery. And it's so new, it was only released to the public 3 hours ago. So this is really hot off the press. And let me just share my screen. And it comes from, just give me 1 second.
I think they call this exclusive news. This is exclusive for Space Oddities, folks.
Absolutely. This comes from Southern Observatory at Paranal in Chile, where they have an instrument called the VLT, which in true telescope tradition stands for the Very Large Telescope. And they've been using its spectrometer, and they've discovered something quite amazing. So, question for the panel: where would I find the Tarantula Nebula? Where would I find the Tarantula Nebula? Because this is what it concerns.
Is it in the Large Magellanic Cloud?
It is. It is. Exactly.
Ooh, I'll get a point.
Yeah, well remembered from the chat we had about it just 2 days ago. So let's go on a tour of the Large Magellanic Cloud. The Large Magellanic Cloud is a dwarf galaxy orbiting this way, and the Tarantula Nebula, we're going to zoom into it. And there it is. The Tarantula Nebula.
Andy, there's lots of music. Can't hear you very well.
So this is a star in the Tarantula Nebula. It's a blue giant star. And a team at the VLT have been combing the Tarantula Nebula, looking at over 1,000 stars to find stars that might possibly have invisible black hole companions. Because it's thought that many stars do, but of course the black holes are very difficult to find. This particular star, thanks to something called the radial velocity, where the star is actually swinging in a circle, thanks to the gravity of something unseen, is accompanied by a black hole. Now, what makes this discovery interesting is that this is what's called a dormant black hole. There are no X-ray emissions coming from an accretion disk around the black hole with superheated material radiating X-rays. It was only found because of the star doing exactly what you see here. As the black hole and the star co-orbit each other, the star moves around in a circle, and this is how many exoplanets are discovered. But because of the strong gravity of the black hole, the movement was more of the star is more pronounced, is more extreme. This black hole is about 9 million times the mass of the sun. It's about 25,000 times smaller than the star that it's co-orbiting. And there's something even more interesting about this black hole. It appears to have formed without a supernova explosion. In other words, there is no supernova remnant to be seen where this black hole is. So the idea is that the star that produced the black hole, the so-called progenitor star, started to go supernova, but immediately collapsed into a black hole, and the remnants of the star were sucked immediately into it without there being a supernova explosion. Now, this means basically you would have had a star that just disappeared in literally an instant. And it's not the first time this has been observed. Here we have an example of a star called N6946BH1, and it was observed many times. This image on the left is an observation from 2007. In 2009, the star started to brighten. And again, it's a blue supergiant star. Astronomers thought or assumed that the brightening meant that it was going to go supernova. But when they looked back at the same area in 2015, shown on the right, there was nothing. No supernova remnant, nothing. The only thing that remained is a very faint infrared glow. And what they think happened here, it's never been definitively proved because there could be a couple of other explanations, like dust getting in the way. But what they think happened is exactly that, is what's called a failed supernova, that the star started to go supernova, but before it could actually explode, it was sucked into the black hole that it had just given birth to. And literally, it happens as quickly as this. Here we have an image of a blue star. It's about to go supernova, and it suddenly disappears into the black hole, and it happens literally as quickly as that. So this is very exciting news from the VLT, that they've identified, first of all, a dormant black hole, and it lends credence to the fact that many stars might have these black holes co-orbiting, but we're not able to see them. And secondly, that there's no supernova remnant, so it could well be a failed supernova, of which I now think there are 3 or 4 examples. But there we are. There you have it.
Andy, have they got any idea of the mass of that second black hole that just appeared, disappeared or appeared, or whatever you want to call it?
Well, no.
No. Okay.
No, because they can't detect anything there. There's just a faint infrared signature, which could be heated material around the black hole, but it's completely invisible.
I think if I read correctly, they're doing a wobble study using the Gaia survey to try to figure out what the relative speed is of some of those stars around that area.
Oh, really? That'd be interesting.
Yeah, but it'll be a multi.
That might give them a good clue.
Yeah.
Yeah. Oh, thanks, Kareem. There we are. So interesting news from Chile.
Lou, you're on mute.
And what was the mass of the first black hole, Andy?
9 million times the mass of the sun.
It's huge.
Yeah.
And they think that this is a collapsed star?
Yes.
Well, that would be quite a massive star.
Yes, it would.
That's just what I was thinking, and it surprises me that it isn't disrupting its binary star.
Yeah, that's true.
With that huge mass.
Let me check that, guys. I may have said that wrong. Just give me a moment, and I will tell you. It may be 9,000, not 9 million. But,
still big, strikes me.
Oh yeah. Just give me a moment. Carry on. Talk amongst yourselves.
No, it's fine. Andy, just come back to us later on. We'll just move on. We'll just
confirm it, because I'm doubting myself now.
Sorry, Andy, didn't mean to trip you up there.
No, you're not tripping me up. It's good to get these things right.
Yeah.
That's the nature of the show, guys. We just talk, and sometimes someone needs to go and cross-check his sources.
This is what science is about, right?
Yes.
Absolutely.
Whilst we're cross-checking, can I just apologise, because poor Ed has just said he's only teasing, but apparently I'd got his name as Ed Holt on the message instead of Ed Holt on his picture today. So I'm sorry, Ed. How could I?
I should say it's a good job people don't cross-check much of what I say, because we would never stand up in court.
Well, Steve, do you have something to present to us tonight?
Nothing to present, I'm afraid, other than at the moment I'm gearing up to the Blue Dots Festival. It's worth mentioning that. It happens at Jodrell Bank I think it is the sixth time, excuse me, that it's has happened. 2 years, of course, went by without it because of the COVID situation, but it's happening again this year. It's an astronomy and science festival, and it commences on Thursday evening with a special performance on the 21st, and then goes through to the end of Sunday, the 24th. And there are music performances throughout the day. It's usually really well attended with lots of family groups as well. It's a fantastic experience there. I believe there could be something like up to 30,000 people, perhaps over the whole weekend. Bjork is there on the Sunday with the Halley Orchestra from Manchester. That sounds really interesting. Groove Armada are another act, I think, that are headlining on the Friday night. So it's a fantastic festival. If you're in the vicinity, you will have to, of course, book tickets in advance. But I would commend it. It looks to be dry this year as well, so it should be very thoroughly enjoyable. By the way, I should say, we at Macclesfield Astronomical Society will be doing solar observing there. We've been invited and asked to represent Jodrell Bank, along with the University of Manchester Astronomy Group, to do solar observing during the day. In previous years, we've done nighttime observing as well, but this year that's not going to work out.
Oh, look, that sounds super exciting. Just a word of caution, Steve. I caught COVID when I went to the music festival in London in Hyde Park, surrounded by 65,000 people. So, go at your own risk, is unfortunately.
Thanks for those encouraging words. But yeah, because I now work at Jodrell Bank Centre for Engagement at weekends anyway, as an explainer there.
Sure. No. Well,
it occurs to me that it is bound to come my way at any time soon. So you might not see me next week here on the Monday.
Just use a astronomy themed mask so that nobody will ask you to take it off, because it'll fit.
I've got one over there actually, but
There we go.
it might improve my looks as well.
Or a large plastic bag, I would recommend.
Can I just say I checked the mass of that? I don't know what I was thinking. It's 9 times the mass of the sun, not more.
Oh, that's yeah.
But it's still pretty heavy black hole.
Yeah.
Good sleuthing there. I think the most massive star, maybe not black hole, but star to date that has been discovered is about 220 solar masses. So what is that? R13, A6, A1, something like that.
That's the one. Yeah.
Something, I don't know. Something like that.
But I mean, that must originally have been a big star as well, obviously.
Yeah.
9 times the mass of the sun, if that's the mass of the core. So
cool.
Yeah. Good
Thank
sleuthing.
you. Thank you so much, Andy, for cross-checking that. Lou, let's jump to you.
Yeah, so we're going to continue our series on exoplanet detection. And if for those of you who've been following us, by the time we finish this, you will be exoplanet experts. So I'm sure we'll have a certificate or something for you, and you can present it to your graduate program. So we've talked about the first detection, where the pulsar that the planet was orbiting, where its timing was thrown off a bit by the orbiting planet. We've talked about radial detection method, where the star is pulled towards us and away from us similarly, but we detect that through the change in the frequency, through the Doppler effect, the change in the frequency of its spectrum. And today we're going to talk about the holy grail of exoplanet detection, and that is the transit detection method. This is a method that has produced the most identifications of exoplanets to date. That may change with JWST and its ability to actually image planets. So let me share my screen a little bit here.
Just while you're doing that, Lou, we have a question in the comments, I think, Rachel.
Yes.
Yeah, I've just popped it in. He's asking, he's bought a Celestron Skymaster 20x80 binoculars. Is it good for astronomy? What can he see with it? Can he find any deep sky messy objects or planets?
They're a little bit heavy, but they're fantastic if you have a nice chair to sit back in. And I especially love looking all around Sagittarius in the summertime because you can see the lagoon with the binoculars. You can see some of the clusters, but you can especially see kind of the arm of the Milky Way. And then look for Andromeda, star hop to Andromeda with your binoculars. And as soon as you figure out how to do that, you're going to fall in love with looking at Andromeda with binoculars.
Yeah. Binoculars are excellent for viewing. If they are too heavy and you find that they are a bit too much to handle, there is a device called a parallelogram, I believe it's called, which you can set up beside your deck chair. And once you've set up the angle, you can move them anywhere and they will stay on that object. So you don't have to hold them so much. But also, you will be able to see messier objects and you will be able to see the planets.
There we are then.
And the moons of Jupiter, which are fantastic to see with binoculars, and even just a basic tripod will do the trick.
Yeah.
And Titan, let's not forget Titan.
Oh, of course.
Yes.
Right, back to Luke.
Yes.
Okay. All right. So sorry for having that animation up while you all are talking. The transit detection method takes advantage of the fact that for some planetary systems, the planet moves in front of the star as we see it from Earth. Its orbit is kind of planar with our view, and therefore blocks out a little bit of the sun, of that star's light. And so I can show that here. Do that. There we go. Here we go. So this is a graphic showing a planet moving in front of its star in its orbit. And you can see the light from the star dimming and then recovering. And you can actually tell quite a bit about the planet and the star from this kind of back and forth. First of all, obviously, you can tell what the period of rotation of the planet is. If you look at the angle with which the light is diminished and then recovering, that angle, you can tell a little bit about the atmosphere of the planet, right? A planet with no atmosphere would kind of cut the light off much more cleanly. If you know something about the star from its spectrum and its size, you can tell what the inclination of the orbit of the planet is, and also the size of the planet. So you can get quite a bit of information out of this transit detection method. The problem is that it only works well for, again, planets that orbit within the plane of, or close to the plane of our line of sight. And so this method actually favors very large planets that orbit very close to their star, because we're more likely to see some of the star's light obscured from those kinds of planets. Let's see if we can go forward here. Here's another example of using the transit detection method to detect planets around another star. In this case, we have, I think, 6 planets orbiting this star. And you can see the periodic data dropouts, the diminishing of light periodically from each of these planets. And so by observing this, you can kind of tease that apart and tell that it's a multi-planetary system, and do the other analysis that we just talked about to try to define the nature of the planets and their orbits. So this is a very powerful method of detection. And one of the reasons we have made so many discoveries about this is we not only have ground-based telescopes looking for transiting planets. We have Kepler spacecraft. We have the TESS spacecraft. And certainly we're going to discover other planets with JWST, probably through imaging as well. So go to the next slide. Here's a, I think I brought this slide up a couple of weeks ago. Here's a kind of an accounting of the number of planets that we've discovered from each of these different kinds of exoplanet detection methods. And we're going to go over a lot of these in this series. So you can see in the red down here, we have the radial velocity detection method. It's a lot of detections. And we're sitting right on top of it in the green is the transit detection method. Most of the stars, most of the exoplanets that have been discovered to date have been discovered by the transit detection method. So I'm just going to end here with once again with the website for the NASA Exoplanet Archive. If you want to know how many planets have been detected, what they're like, what stars are orbiting, where they are, anything you want to know, the NASA Exoplanet Archive has lots of great information, and you can check this out. So that's what I have for you today.
Great, thanks, Lou.
Yeah, great. Thank you so much. Is it possible, Lou, to put the link of the NASA Exoplanet Archive maybe in our internal chat, and then we can push this back to the YouTube channel?
Glad to do that.
I will add the link to the description of this video a bit later.
Okay, all right.
Yeah, that would be great. That's fantastic. I didn't know there was such a data set hosted by. I mean, obviously it's obvious. I just never really looked for it as such.
I use it when I give talks on exoplanets, and I always have to go back to this archive because the numbers, of course, are increasing. Number of planets detected, number of multiple planetary systems detected, and so on. So I have to stay current, and the NASA Exoplanet Archive helps me do that.
I have a question for you, Lou. I mean, obviously, you know, we talked about tests and things, but if I remember well, Gaia might also be able to provide data, even though it's not as, you know, the resolution of the Gaia data is not as good as tests. Can you provide a bit more background on
I
that?
forgot to include Gaia. You're certainly right about that. And depending upon the methods that you're using, many more spacecraft, including Hubble, by the way.
Cool.
So yes, many spacecraft have a role in identifying planets around other stars, including Gaia.
Basically, anything that looks at stars, we might be able to find a way to extract some meaningful data, transit data from that, right? That's cool.
I think it's
the orbit is right. Yes.
I think it's an example of how perverse the universe can be sometimes, because the first exoplanet ever found was orbiting a pulsar, which is not somewhere you would actually expect an exoplanet to be, indicating that it survived a supernova explosion. So I think the universe sometimes turns around and says, "Oh, you think you know stuff? I'll throw this at you. And what do you think about this?" So there we are. You know, this to me is still science fiction, that we've now got over 5,000 planets. And sometimes I like looking at art that artists have done of these other planets and views from these other planets. And some of them are just absolutely so evocative and so beautiful.
Right. And from this very small database, remember there are billions of stars in galaxy, perhaps 400 or 500 billion just in our galaxy. From this very small sampling, we think that there are roughly as many planets as there are stars, perhaps in the universe, certainly in our galaxy, which just boggles the mind.
It's mind-blowing. And yet some people still think our planet is in some way special or different to the rest of the universe.
Well,
I mean, it is obviously.
We have Netflix. I mean, I challenge you with Netflix.
Yeah, but you know, it's our planet does not occupy a special place in the universe. That there are billions of planets out there. So yes, exciting stuff.
Totally. I personally can't wait for JWST to start looking at the TRAPPIST system, which was discovered through.
Well, it's meant to be happening. They had it down for this week, the observation. So I don't know if it's happened yet or whether it's going to happen. Nothing released yet, obviously. So yeah,
it's around this time, that was for sure.
And there's multiple groups with projects on the TRAPPIST-1 system looking at different ones of those exoplanets.
Yeah.
And
Yeah.
one of them is working. You had them on the call, right? Kareem was this Canadian astronomer.
Olivia Lim, yeah, we've
Yeah.
talked about her before, and the supervisor of that, or the coordinator for the IREX Center was on with us, Natalie Willette.
Yeah,
Right.
so
Right.
super cool.
But don't you think?
Very good.
Don't you think that it's incredible the achievement with WASP that we managed to detect water in the atmosphere of a planet trillions upon trillions upon trillions of miles away. You just can't get your head around that achievement.
It's mind blowing, isn't it?
It is. And God,
And it's only the start.
it's only the very
Yeah.
beginning. And you know, if Louvois ever gets built, the successor to the James Webb, projected launch of 2039, and NASA have hedged their bets a bit on this one because they've got two possible versions, a 9-meter mirror and a 50-meter mirror, and they'll build one of them depending on how much money they get. But the capabilities of the 50-meter mirror, can you just imagine that? Well, I can't. It's going to be. I won't be here to see it probably, but it will be truly amazing.
This is why we really needed to get past the near infrared into the mid infrared, right? Is to be able to see all the molecules, because
Sure.
that's where the richness is of what we're looking for.
Yeah.
Sorry, Lou, I cut you off.
No, a very important statement there, Kareem. I was going to say this gives me a little empathy for members of the public. It seems like there are kind of two groups when we talk about things like this that are almost impossible to wrap your mind around. One of them says exoplanets, wow, life, multiverse, wow, and they just go, time travel. And the others say, no, this is impossible. I don't believe this. I don't believe in science. This is crazy stuff. So I guess
the number of people on social media that are screaming fake about the JWST images that were released. It's truly depressing. It's truly depressing.
I had somebody, was it yesterday, that was coming on about my images that me and Jonathan had done and just put fake, didn't sort of expand on it. And sort of when I'd asked, it was like, oh yeah, of course, you're taking those pictures with that telescope. And I was like, yes, we are. And then he said, so with that telescope, you can do better than the James Webb. I was like, well, thank you.
That'll be interesting. That'll be interesting.
But, they don't stick around to hear the sort of the evidence and the answers. It's just sort of throwing grenades in and running off.
I think they just have aperture envy. I think that's,
Yeah. Don't we all have aperture envy?
You speak for yourself, mate.
Going back to Louvois and these, potential amazing new instruments we will have in a few decades. I'm actually even more excited for the discovery of maybe even beer in the atmosphere of another solar system at some point. Yeah. Das, do you have something to share with us today?
Not really. But you were talking about the beer. That was this has been known. Yeah, it did. I could do with one right now. But it's an old. We've known for a long time that alcohol clouds do exist in the interstellar medium, and these clouds are so large that basically you got to just bring your own straw. But the thing is, it's not the alcohol you want to be drinking. You're talking about ethanol and is it pethanol and things like that. It's the relations to it. It'll give you a bit of a jippy tummy and hell of a head. It's these alcohol clouds. It'll be interesting to see if they can actually do anything with them. But I think they've even been detected in our own Milky Way, so they're not far off. Just got to get a delivery van to pop out there and I
bet you Father Jack would drink it, Daz.
Yeah, Father Jack from Father Brown. Yeah, not Father Brown. What am I on about? That's another program. So yeah.
Cool, cool. It will be a pit stop on the way to
Exactly,
visit
it'd
another
be a
place.
party. I mean, you'll be totally useless when you get anywhere to do any science. You know, it's just
cares?
going to be it'd be a hell of a party, though, won't it?
Well, I've always said that you know, there's a big link between astronomy and alcohol. I mean, they both got two O's in the words for start. They both involve lying on your back looking through cylindrical objects.
You should come on one of my field trips.
Right, Bernard, did you want to say something? You had something to present.
Oh yeah, you know what, guys? I had something, but it's fine. I can. I'll do it for next week. I wanted to do a presentation. Yeah, on New Space. I'm writing an article for an organization, and it's on the New Space. So this new environment within the space tech industry in Europe, mainly focused on Europe, and through my research, I've been finding quite a lot of interesting things. But you know what? I have to finish my article next week anyway, so I'll probably work on it and then come back with a nice juicy bits and very interesting points of view on that. So yeah, thanks. Well, there it is, guys. Thank you so much for joining us tonight. I personally had a blast, and I know everyone on the panel had as well. Yeah. I hope you enjoyed yourself. Please don't forget to subscribe and to like. Only through subscribing and like will we be able to get better known and to have more people viewing us, and we'll be able to do even more things. Don't forget as well to submit images to Rachel. Rachel's put the link as to how you can submit your images. We love your images. They're just mind-blowing. So please do keep them coming. And that's it. That's it from us. So we're all going to say goodbye. Goodbye, the panel.
Thank you. Thank you very much. Thank you.
Goodbye.
Don't forget
Bye.
Send your questions in. Send your questions in.
Yes, send your questions in if you have any questions, and we will see you all next week at the same time, same place, right?
Definitely.
Hit the like. Hit the like,
everybody, and stay cool. Bye.
Cheers.
Bye,
Thanks a lot.
everyone.
Bye, everyone.
Bye.
Ta-da.